Hi guys, welcome to another video. Today we will be solving class 9 number system exercise 1.5. Now the first question says classify the following numbers as rational or irrational. We know that 2 is rational, root 5 is irrational. So the difference will definitely be irrational as this will give me a non-terminating and non-repeating decimal expansion, so we will not be able to solve it completely. Over here, when I open the bracket, I will get 3 plus root 23 minus root 23. This and this will get cancelled as they are additive inverse, and I'll be left with 3, which is a rational number denoted by Q. Here root 7 and root 7 will get simply cancelled, and I will be left with 2 upon 7, which is again a rational number denoted by Q. Next, 1 by root 2. Again, if I want to make it easier for me, I can simply rationalize it by multiplying both the numerator and denominator with root 2, and I will get root 2 upon 2. Now, root 2 upon 2 cannot be solved completely, thus we can say it is irrational. And as we are aware that pi is irrational, so the product of 2 and pi will also be irrational. Moving to the next question. Now we have simplified each of the following expressions. Now in this, we can simply do double distributive property. First, I will multiply 3 with whatever is inside the bracket. Then I will put an addition sign as there is an addition sign here. Then I will multiply root 3 with whatever is inside the bracket. Then I will get 6 plus 3 root 3 plus 2 root 3 plus root 3 into root 2 will give me root 6, and this can be added because root 3 and root 3 here will act as variables. So I will get 6 plus 5 root 3 plus root 6. Next one. Now this is easier as it can be solved using the property a plus b into a minus b, which gives me a square minus b square. So I have 3 square minus root 3 whole square. So I will get 9. Root and square will get cancelled and I will be left with 3, which is 6. Next part. Now this is again an identity, which is a plus b whole square, which gives me a square plus b square plus 2ab. So I get root 5 whole square plus root 2 whole square plus 2 into root 5 into root 2. Here square and root get cancelled, same here. So I'm left with 5 plus 2 plus 2 root 10. 5 plus 2 can be solved to 5 plus 2 root 10. Again, this is an identity, a minus b into a plus b, which gives me a square minus b square. So my a is root 5 and my b is root 2. So I'm left with 5 minus 2, which is 3. So the question says recall pi is defined as the ratio of the circumference of a circle to its diameter. That is, pi is equal to c by d. This seems to contradict the fact that pi is irrational. How will you resolve this contradiction? Now we must remember that the circumference and diameter is just a measurement. That means we have compared it to a known quantity, right? And thus it is just an approximation. We say it is just an approximation. Thus, when we find the ratio, we are just finding the approximation of that. So therefore, we are not contradicting pi is irrational, as we are only taking an approximation or a rounded off value in this case. Okay. Next question, guys. So the next question says represent root 9.3 on a number line. So this we will draw a straight long line first. On that, we will mark A, from A we will measure 10.3, one more than what is needed, and mark it as C. And then from A I will again mark B, which will be at 9.3. So AC is 10.3 and AB is 9.3. Then I will draw the perpendicular bisector of AC. I will draw the perpendicular bisector of AC. If you remember, it's simple. By taking little more than half, then drawing two arcs here, then two arcs here. They will meet somewhere around here, and I will mark that point as O. Then taking AO as my radius, I will draw a semicircle till C. Then from B, I will simply draw a perpendicular. From B, I will simply draw a perpendicular. From B, we will simply draw a perpendicular and name it as D. Then I will join O and B. Then we will simply join O and D. When I measure OD, when I measure OD, it will be my root 9.3. This OD will be my root 9.3. Now, if I start from O, taking this measurement, and I draw an arc from O, it will intersect somewhere around here. It will intersect somewhere around here, and I can mark this point as E, and the OE will also represent root 9.3 on the number line. Okay, so the next question says rationalize the denominators. So the first one is easy. We need to remember that we need to multiply with the conjugate. So the conjugate of root 7 itself is only root 7. So I multiply both the numerator and the denominator. Whatever happens to the denominator must happen to the numerator also. So I get root 7 upon 7, which cannot be solved further, and the denominator has been rationalized. In this case, when we have two irrational numbers either being added or subtracted, the conjugate is the same rational numbers with the opposite side in between. So I multiply both the numerator and denominator. Now this becomes the identity a minus b, a plus b, which should give me the numerator becomes this, and denominator will be root 7 square minus root 6 square. So which gives me root 7 plus root 6 upon 7 minus 6, which is 1. So I get root 7 plus root 6 upon 1, which is a rational number. Next part. Now it's quite similar to the previous question. I can simply multiply it with the conjugate. I will get root 5 minus root 2 into root 5 minus root 2, both the numerator and denominator. So numerator becomes root 5 minus root 2, denominator becomes root 5 whole square minus root 2 whole square, as again I have the property a plus b into a minus b. So the answer is root 5 minus root 2 upon 5 minus 2, which gives me root 5 minus root 2 upon 3. This one can also be done the same way. So I can write the question again. Into root 7 plus 2 into root 7 plus 2. So I am left with root 7 plus 2 upon root 7 whole square minus 2 square. So I get root 7 plus 2 upon 7 minus 4, which gives me root 7 plus 2 upon 3. So the denominator is a rational number. So that's it for today. Please like, share and subscribe to my channel for more updates. Thank you.